Today we're going to be talking about arc length of a curve. And what arc length is basically if I had a rope and I put that rope all along this arc, what the length of that rope would be. So our goal today, and to do a few examples with it, is to define this arc length. Okay, so let's look at this here. We're going to split our arc length up into different intervals, kind of like how we found area. We split it up into different intervals, and these all look like trapezoids. So let's look at one of these trapezoids. So one of those trapezoids, L sub k, the length of that is, from the Pythagorean theorem, square root of delta x squared plus delta y. And I guess technically that should all be in parentheses squared. I don't know why that keeps disappearing. I'm using a new thing to record my video, so I apologize. Okay, so let's factor out a delta x from this. So if I factor out a delta x squared, we get, I apologize, there should be no equal sign there, 1 plus delta y squared over delta x squared. And then simplifying that a little bit more, the square root of delta x squared is delta x outside. And then inside we have 1 plus square root of delta y over delta x squared. Okay, now going over here, if I were to sum up all of these, so using our sigma notation of this thing, and then we have our delta x, what does that become? If you think about it, remember when we summed up a bunch of different areas, a bunch of different, in this case it would be like maybe trapezoids or whatever, summing up a bunch of different things, that was an integral from a to b of the square root of 1 plus, now delta y over delta x, what is that? That's our function's derivative. And then dx and delta x becomes our dx. So, arc length of a smooth curve, okay? And this is a formula you want to know. If you're looking at the curve in terms of x, so you're finding the length of the curve in terms of x, where y is a function in terms of x, it's this top formula. But then if we were finding the length of the curve in terms of y, so if our curve looks something like that, and we're going from C to D, you would use, since that's a function of x in terms of y, it's not a function of y in terms of x, you would use basically integration, but you'd have everything in terms of y. Okay, so finding the length of this arc from 1 to 4. Since y is a function of x, we're going to do everything in terms of y. So the length of our curve is going from 1 to 4. The square root of 1 plus dy dx squared dx. Y prime is 3x squared. So I'm finding the integral from 1 to 4 of the square root of 1 plus 9x to the 4th dx. When we find that in our calculators, we get 63.124. Okay, next example. Let's find y prime. Don't forget your chain rule, 2 cosine 2x. So I'm finding the integral from pi over 4 to pi of the square root of 1 plus this thing squared, 4 cosine squared 2x. And again, just type that in your calculator, and we get 3.953. Now in this case, I have our function in terms of, I'm going to use a different color. I have our function in terms of y. So I need to find, instead of dy dx, I need to find dx dy, derivative of x with respect to y. So that is e to the y minus the sine of y. So I'm finding the arc length from 0 to 10. That's a 10 there. That is 16, that's a 10. Ah, okay, let me just erase. Zero to 10 of 1 plus e to the y minus sine y squared dy now. And again, that's plugging into your calculator. We get that value. Now, one of my favorite problems on the AP test is, I'm just going to move this up because I'm going to need a little bit more room. Okay, it's not going to let me move it up. Never mind. One of my favorite problems in this case is to find the perimeter of a region. So up in this top corner, I'm going to talk about what that area looks like. So I'm going from 0 to 4. Actually, I need a little bit more room. I'm going to erase. I apologize. I did not plan that out correctly. So I'm going from 0 to 4. This is my y-axis, this is my x-axis. Let me label stuff. And this is 1, 2, 3, and 4. We have y equals x squared, which we know looks something like that. Oh, that's a really bad curve. That's okay. And then we have y equals 2 cosine x. So up here at about 2, somewhere in between 1 and 2, we hit the x-axis and we curve down like that. So I'm finding the perimeter of this. I like to split it up. I like to split it up into, I'm going to say that region's A, this is B. I don't know why those are erasing. C and D. Okay, so A is our integral from 0 to 4 of the square root of 1 plus derivative of that function squared dx. That function is, the derivative of that function is negative 2 sine x. And when I get that value, I get 6.416. Now B is easy. I'm going to do B over here just to save myself some room. B, that's 2 units. D, actually no, let's do C next. C is what this value is. Well, big, so big minus little. So I take the big, which is, I'm just going to do the absolute value. That value is negative 16. This value is negative 2 cosine 4. When I find the absolute value of that, I get 14.693. And then for D is the integral from 0 to 4 of the square root of 1 plus derivative of the function squared dx. Derivative of that function is negative 2x. Finding that value, again, all of this is calculator work, is 16.817. Now I sum up all of these, and I sum them all up, and I get 39.927. Okay, so in this example, we need to find the length of the curve described by that equation. Now notice how it's an integral, so dy dx ends up just being what that curve is. So I'm doing the integral from 1 to 4 of the square root of 1 plus that thing squared is just x cubed minus 1 dx. So that simplifies to the square root of x cubed dx. Now I can do this without a calculator. And that's like saying x to the 3/2. I'm going to write it as a fraction just so that I don't screw up my antiderivative. So when I add 1 to my exponent and take the reciprocal, I get x to the 5/2, 2/5, evaluated from 1 to 4. So I have 2/5, 4 to the 5/2, minus 1 to the 5/2. Okay, so I square root 4, which is 2, and then I take 2 to the 5th, which is 32, minus 1, 31, so that gets me 62 over 5. So again, that would be considered a non-calculator question.